6th grade math with Mr. Anderson.
Alright class, today we'll be talking about two things. The first thing we'll be talking about is line symmetry, and then the next thing will be rotational symmetry. So let's start with line symmetry. Now you've been doing line symmetry, probably since kindergarten, I believe. So you guys should have a pretty good idea what line symmetry is. Well, what is line symmetry? If you can divide a figure, a shape, a picture, into two different congruent parts or mirror images, then you can say it has a line of symmetry. Okay? And some shapes have multiple lines of symmetry. Well, let's take this ladybug type beetle here. Are there any lines of symmetry here? Well, yeah, there's a vertical line, isn't there? If I drew a line, oh, not like that. Let's try that again. I want the pen. If I drew a line straight down, oh, does it work because it's black? I'll try red this time. If I drew a line straight down, as you can see, it would fold onto each other. They'd be exactly the same, wouldn't they? So we could say this has one line of symmetry. Okay? So we could say that, yes, this is symmetrical. Okay, one line of symmetry. So let's look at a few other examples. Let's look at the letter B first. Do you see any lines of symmetry on this? If so, how many? Well, do you see the horizontal line right here? How you could fold from bottom to top and it looks the same? It's a mirror image. Yeah, so is there any other lines of symmetry? Nope, that wouldn't work, would it? So this one just has one horizontal line of symmetry. How about the W? Does that have symmetry? Here's my vertical line. See, if I fold it right on that line, it would cover up both parts, wouldn't it? Looks like two V's, doesn't it? How about the C? Does the letter C have a line of symmetry? Not that way, right? You couldn't fold the left side to the right side. Okay? But it does have the horizontal line there. You could fold the top to the bottom or the bottom to the top, and it would fit right on it. So it does have one line of symmetry. Here we have a hexagon, right? Whoa! Didn't mean to do that. I'll just keep it where it is. I don't know why I moved it. Okay. Does this have a line of symmetry? You should be saying yes in your head right now. If so, how many lines of symmetry does this have? 1, 2, 3, 4, 5, 6, 7, 8? What do you think? Well, let's see. If I draw a line right down the middle. Oh, not the straightest line. But you kind of get how it can fold. And if I drew a line like this, that's the second line of symmetry. Top and bottom would fold. Any others? How about right here? Yep, that would fold in the diagonal. So that's the third line of symmetry. How about here to here? There we go, that's the fourth. Any more? How about from this corner to this corner? There's the fifth line of symmetry. How about this corner to this corner? Aha, that's number 6. It folds right on that line. So this hexagon, it's a regular hexagon, has 6 lines of symmetry, doesn't it? Okay? All right. Look at the square. Why don't you draw a square somewhere and draw on your lines of symmetry and see if you got the same as me. Go ahead and do that. There's one. There's two. Any more? Yes. Here to here. You get two triangles that fold on top of each other. And here to here. Another triangle. So this has 4 lines. Okay? So here's a rectangle. Draw a rectangle on your whiteboard, your piece of paper, and draw on your lines of symmetry. You'll check with me. So we've got a horizontal line here. We've got a vertical line down the middle. That's 2. And that's it. There's only 2 lines of symmetry on a rectangle. I bet some of you did this. You did a diagonal. Oh, it wasn't quite right, but see if I can move it a little bit. Okay, it's better. Now, is that symmetrical? Look at this little space right here compared to this big space. If I folded it on that line, it wouldn't line up, would it? So no, this is not, the diagonal on a rectangle is not symmetrical. It's not a line of symmetry. Okay? Does this have any lines of symmetry? It absolutely does. Right here I can fold it. It would fold right on top. And right here I can fold it. Bottom to top. Right? Any more? How about right there? I can fold it right there. And right here. Okay? So it actually has many lines of symmetry on here, doesn't it? Alright, so that's what your first IXL is all about. Does it have a line of symmetry? Does this heart have a line of symmetry? It sure does. Right down the middle, doesn't it? And that's the only one. Okay? How about this butterfly? Ooh la la. Where would it go? Up and down? So a vertical line. The left side would be the same as the right side. It would fold right on top of the other one, wouldn't it? Okay? Alright, so that is lines of symmetry. Things you have definitely done. I even have my first grade daughter in here, and she's saying, yes, yep, yep, that's a line of symmetry. Okay. So the next thing we're going to talk about is rotational symmetry. Rotational symmetry. Which means if I turn or rotate the object, would it look exactly the same? So if I take this bug, this beetle, okay, and I turn it, will it look exactly the same? No. 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 So only if I go all the way around, which doesn't count. So this does not have rotational symmetry. Now compare it to this hexagon here. If I turn it, you see the original. Turn it here. Ooh, it looks exactly the same, doesn't it? I turn it again. Ooh, yeah, looks exactly the same. It has rotational symmetry. I can move it to the side here. And if I turn it, will it look exactly the same? Right there. Right there. Looks exactly the same, doesn't it? See how I rotate it? And it'll look exactly the same as the one on the left. So we say, yes, this does have rotational symmetry. Does that make sense how I turned it? And it looks exactly the same? And I can do the same with this square. So if I turn it, nope, 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 90-degree turn, boom. 180-degree turn, yes. 270, yes. And all the way back to the front, to the top there. Okay, I'll go to the side. I turn it. It looks exactly the same. Looks exactly the same, right? Same with here. So yes, it does have rotational symmetry. How about this rectangle? Does this have rotational symmetry? If I turned it, what do you think? Clone that. There we go. Let's see. So if I turn it 90 degrees, no. If I turn it 180, yes. So it does have rotational symmetry when I rotate it. So it looks exactly the same as the one on the left. How about this one? Does this have rotational symmetry if I turn it? Will it look exactly the same? What do you think, Lyndon? No? Does it look exactly the same?
Yeah.
So it'd be yes. Good job. Does it look exactly the same now when I turn it? How about now? Yeah, so it does have rotational symmetry. Does this heart have rotational symmetry if I turned it? Lyndon says no, my daughter. She's in first grade. No. Nope, it's upside down. It doesn't look exactly the same. Nope, we're back to the top. So you are right, Lyndon. It does not have rotational symmetry. Good job. How about this butterfly? Rotational symmetry?
No.
No? Yeah, now it's just upside down. It doesn't look exactly the same. So that'd be no. Okay, look at the flower on the left. The flower on the right, they're identical, aren't they? Does this flower have rotational symmetry? My daughter says yes. Do you say yes? Let's see, I'm going to rotate it. Oh, we got to scoot it over. Does it look exactly the same? There it does, right? There it does. So it does have rotational symmetry. There it did too. I think I missed that one. And I believe... almost. Okay? It definitely has rotational symmetry, especially right there. Okay? So yes, it does. She got it right again. Man, she's good. This orange. Rotational symmetry. If I turn it, let's see. She says yes. Does that look the same?
Yeah.
How about now?
Yeah.
How about now?
Yeah.
Oh yeah. Yep. Definitely has rotational symmetry. I'm getting dizzy. Okay. How about the snowflakes?
Yeah.
Does that have rotational symmetry? You should be answering this in your head. I'm going to turn it. What do you think? Yeah. She's right again. Man, she's good. She's really good. Yeah, it has rotational symmetry, doesn't it? When I rotate it. Okay? That's it. That's the lesson. Okay? So, go on to your IXLs, and if you have questions, see me in class. If you don't have questions, still see me in class, okay? All right. Good luck.